So something pretty big just happened in the world of AI and robotics, something that could actually change how we interact with machines in the next few years. Google's DeepMind just dropped alphaevolve, and it's not just another flashy AI. This system is literally evolving algorithms, not writing code like a chatbot, but inventing new, better algorithms that outperform what humans have spent decades building. It's already saving Google millions by optimizing their infrastructure, and get this, alphaevolve just shattered a 50-year-old math record. We're talking about an AI that redesigns hardware, speeds up Gemini training, and rewrites the rules of computing, all by mimicking natural selection. This isn't science fiction, it's happening now, and it's changing the future of code forever. Let's dive into something absolutely mind-blowing from Google DeepMind. They've just unleashed a new AI system called alphaevolve that's shattering boundaries in the tech world. This isn't just your typical AI announcement. It's literally evolving algorithms independently. We're not talking about some glorified code generator here. This is an AI that's inventing completely new algorithms that outperform what human experts have crafted. And get this, it's already saving Google millions in computing resources across their operations. Here's the fascinating part. alphaevolve marries Gemini's powerful language models with evolutionary computing principles. It harnesses LLM's creative potential to propose innovative solutions, then ruthlessly tests the ideas through automated evaluators. The weak solutions get eliminated, promising ones evolve further. And this cycle repeats until a superior algorithm emerges. Darwin's principles applied to code in real time. And Google isn't keeping this breakthrough confined to research labs. They've been deploying alphaevolve across their actual infrastructure for over a year now. It's already embedded in critical systems like Borg, the massive platform orchestrating Google's sprawling data centers. Just one of alphaevolve's algorithms has recovered an average of 0.7% of Google's global compute resources continuously. That percentage might seem tiny, but at Google's colossal scale, we're talking about millions of dollars in efficiency gains practically overnight. What's truly revolutionary about alphaevolve is its approach to problem solving. While most AI coding assistants focus on generating snippets or patching small functions, alphaevolve is evolving complete programs. Hundreds of intricate lines of code with sophisticated logical structures. This isn't just autocomplete on steroids, it's designing actual computing infrastructure from the ground up. One of the most impressive achievements so far, alphaevolve optimized a critical kernel used in training Gemini models, specifically the matrix multiplication operation. This single innovation delivered a stunning 23% speed up for that operation, and because it's part of the core training pipeline, the overall training time dropped by 1%. That 1% might sound modest until you consider the massive scale. When you're training models across enormous clusters for weeks on end, that represents substantial time, money, and energy saved. And remarkably, it came from AI optimizing the very system that trains the AI itself. The breakthroughs didn't stop there. alphaevolve also discovered a superior configuration for an arithmetic circuit in Google's custom tensor processing units, TPUs. It essentially streamlined a hardware design that was already highly optimized by removing unnecessary components. This change passed rigorous verification, got the green light from engineers, and is now incorporated into an upcoming TPU design. Now here's where things get truly astonishing. alphaevolve recently shattered a mathematical record that had remained unbroken for over 50 years. Back in 1969, mathematician Volker Strassen developed an algorithm that could multiply two 4x4 matrices using 49 scalar multiplications. For half a century, no one could improve upon this, until alphaevolve arrived on the scene. It discovered an unprecedented approach using only 48 scalar multiplications. That's the first time anyone or anything has surpassed Strassen's record for a complex valued 4x4 matrices. A mathematical barrier that stood firm for more than 5 decades until this AI coding agent cracked it. This isn't just academic showboating either. Matrix multiplication underpins countless processes in everything from computer graphics to machine learning. It happens trillions of times daily across global computing systems. Even a fractional improvement reverberates through innumerable applications worldwide. To be clear, alphaevolve didn't stumble upon this breakthrough instantly. For that 4x4 matrix challenge, it meticulously generated and evaluated 16,000 different algorithm candidates. That's the brilliance of its approach. It's not randomly guessing. It's applying evolutionary principles, proposing solutions, testing effectiveness, refining promising candidates, and iterating relentlessly until the optimal solution emerges. If you're experiencing deja vu thinking about Alpha Tensor or Alpha Dev, that's no coincidence. These were DeepMind's earlier ventures into computational improvement. Alpha Tensor focused specifically on matrix multiplication with binary inputs, while Alpha Dev optimized fundamental computing operations like sorting and hashing. alphaevolve represents the next evolutionary leap. It generalizes the entire process across domains. It wasn't built for a single problem type. Any challenge that can be expressed in code and automatically evaluated falls within alphaevolve's purview. DeepMind rigorously tested across more than 50 diverse mathematical problems spanning number theory, geometry, and Fourier analysis. The results? It matched humanity's best-known solutions approximately 75% of the time. Even more impressively, in roughly 20% of the cases, it actually improved upon existing human-created solutions. This includes cracking and kissing the number problem, a geometric puzzle dating back to Newton himself. The challenge involves determining how many spheres can simultaneously touch a central sphere without overlapping. In 11 dimensions, the previous record stood at 592. AlphaEvolve discovered a new configuration reaching 593. Adding just one extra sphere might seem trivial, but in the mathematical community, this represents a monumental breakthrough. When progress plateaus, meaning newer generations aren't improving, AlphaEvolve implements contingency measures. It might reintroduce an older candidate from a previous round to diversify the gene pool and avoid local optimization traps. This prevents the model from getting stuck in suboptimal solution paths. When all standard approaches falter, Gemini Pro enters the arena. With its superior reasoning capabilities, it's deployed strategically. Like a specialist consultant called in when conventional approaches fall short, Pro can introduce entirely novel strategies that Flash might overlook, and once it produces promising results, the evolutionary cycle continues anew. This process can span dozens or hundreds of generations during a single run. Thanks to automated evaluation, AlphaEvolve tackles problems where feedback is imminent and quantifiable, like performance benchmarks, energy consumption, computational speed, or mathematical precision. The system operates with remarkable efficiency. Tasks that would consume weeks of expert engineering time now complete in just days through automated iteration. Unlike human teams, AlphaEvolve never experiences fatigue, never loses concentration, and can explore thousands of variations that even brilliant developers would never conceptualize. That's why it's not merely generating code, it's discovering genuinely novel algorithms that surpass decades-old human solutions. All through this massive evolutionary cycle, scoring and selecting winners repeatedly until optimization possibilities are exhausted. It's literally evolving code through successive generations. Crucially, this happens within a closed feedback loop with automatic evaluation. The system must verify each result instantly, which explains its effectiveness on problems with a clear objective metric, like data center efficiency or mathematical accuracy. Despite already transforming data centers, chip design, and LLM training, we're witnessing just the beginning of AlphaEvolve's potential. Google has announced its plans to expand AlphaEvolve into realms like material science, sustainability research, and pharmaceutical discovery. Any field involving algorithmic complexity and measurable outcomes becomes a potential application domain. DeepMind is currently developing a user interface with their People Plus AI research team, with its early access program of academic researchers on the horizon. They're also exploring broader availability options for the future. Of course, limitations exist. AlphaEvolve isn't suitable for programs requiring subjective judgment, like interpreting experimental results or creative writing. It demands challenges where solutions can be automatically scored against objective criteria. Additionally, while it produces groundbreaking results, it doesn't always provide theoretical insights into explaining its discoveries. If you need a deep understanding of underlying principles, you might still face unanswered questions. Nevertheless, the practical input remains undeniable. It's fundamentally reshaping algorithm discovery. Rather than meticulously handcrafting solutions, researchers now collaborate with AI partners, bringing complementary creativity, an exhaustively iterative, untiring exploration approach that humans simply cannot match. As language models continue advancing, AlphaEvolve grows increasingly powerful alongside them. Based on current trajectories, this technology is just beginning its revolutionary journey. If this represents AI coding capabilities in mid-2025, the coming years promise extraordinary developments indeed. Which leaves us with a profound question. What happens when the most sophisticated algorithms on Earth are no longer human creations, but machine-evolved constructs, emerging silently from digital evolution?